Hey guys, so here we are with our 9.2 lesson on special right triangles, and there are two of them, as you can see here in the essential question part, 45, 45, and 90. So here's your 90-degree angle in that one. The other two angles in the right triangle would both be 45s. And then there's this other one, it's a 30, 60, and 90. So there's your 90-degree, and then the other two angles, one's a 30 and one's a 60. So we're going to be looking at finding side lengths of these special triangles. We're going to solve a couple of real-life problems with them. First, let's look at a little In the Bleachers cartoon. So it says, we don't know until the MRI, but I'm certain that it's either an ouchie or a boo-boo. So a big football player has an ouchie or a boo-boo. Alright, so let's look at the first special right triangle. That's our 45, 45, 90. So on page 249, there in your notes you can see that theorem. And really what we need to realize from this one, especially on the diagram, and you can see it, and this little kind of equation, think of this as an equation. We will continue to use this as we figure these out. But you can see from the diagram, there's your 90, these other two are 45. The legs are both going to be the same thing. Since the angles are both 45, the legs will be equal to each other. So we're going to call those x, and we're going to go off just what the leg side is right now. So the hypotenuse is always going to be whatever the leg is times the square root of 2. So this, if the leg was just 1, then it would be 1 times square root of 2, which would just be square root of 2. If the leg is 2, then it's 2 square root of 2 for the hypotenuse. So a very easy one to work on and work with. So we got to use this little thing down here, so the hypotenuse. Sometimes we might know the hypotenuse when we're trying to find a leg, and that could be true. So we might use this as an equation. We could, if we did that, if we knew the hypotenuse, we could divide by square root of 2 to find the leg. Alright, so let's go ahead and try a couple of these. Okay, so on page 250 in your extra practice, 1 through 4, we're going to find the value of x, write the answer in simplest form. So these are all going to be 45, 45, 90 right triangles, as you can kind of see. So there's a 45 on that one, so if this is 45, the other side has to be 45 as well. On this one you can tell in number 2 that these legs are the same, so these angles would have to be both 45s as well. Same thing with this one, they're both x, so they're both the same thing here. They're going to be both 45s, and there's another 45 in this one. So these are definitely showing you 45, 45, 90 on all 4 of them. And so to do that, let's go ahead and put down our little equation that the hypotenuse equals the leg times the square root of 2. So we need to figure out what is our x. In number 1, our x is the hypotenuse. So x would be over here, and the leg is 10. So we could see, well, the x is going to equal 10 times the square root of 2. And so that's going to be just our answer there. X equals 10 square root of 2. That's as simple as we can get that. So that one's a very simple one to do. When you know what the leg is, and you're trying to find the hypotenuse, that's really easy. This one is we're trying to find the hypotenuse, as you can see. So hypotenuse is always opposite the right angle. There's the hypotenuse x. So it means that the hypotenuse is going to be our x. We do know what a leg is on this one again. So we're trying to find the hypotenuse on this one also. But our leg is square root of 2 over square or over 2. We cannot reduce that to 1 or anything. Square root of 2 over 2. So we're just going to do this again. Put x here. Square root of 2 over 2 will be the leg times the square root of 2 again. That's what we're getting here. So hypotenuse, this is the leg times square root of 2. That's always what we're looking at here. And so now as we multiply this, we can put this over 1 and make this into a fraction. So now it's square root of 2 over 1. We're going to multiply the square roots together. Square root of 2 times square root of 2 would give you the square root of 4. So 2 times 1 on the bottom is 2. Square root of 4 is 2. And so 2 over 2 would just equal 1. So x equals 1 for number 2. Number 3, we're looking for a leg. So x is the leg here. We're told what the hypotenuse is. So the hypotenuse now is going to be that 8 square root of 2 here. X is going to be this inside here. So we'll start off with 8 square root of 2 equals x times the square root of 2. And now what we need to do is divide by both sides by this square root of 2. So we're going to divide by the square root of 2. As we do that, we'll cancel out the square root of 2 is here, giving us just x. And over here, these square roots of 2 also will cancel out, and it'll just give us 8. So there's our answer then. The answer is just 8. X equals 8 because we canceled out square root of 2. Okay, last one here, number 4. We're looking for a leg. The hypotenuse is 12. So 12 is going to be over here equal to x times the square root of 2. So 12 equals x square root of 2. We can divide again by the square root of 2. And so now we have 12 square root of 2 over here. These square roots will cancel each other out. So now x is equal to this right here of 12 square root of 2. But we need to remember that we cannot leave a radical in the denominator. We have to rationalize that. So we have to multiply top and bottom here by the square root of 2 over the square root of 2. That way this down here would become the square root of 4, which will become a 2. That will rationalize that and make it a rational number. So on the top we have 12 square root of 2 and over 2 now. So the square root of 2 times square root of 2 is 2. And you can see we're going to be able to cancel out 12 and 2 here because they're both outside radicals, and 12 and 2 can cancel each other out. 12 becomes 6, and the 2 will become a 1. So really we're just going to see 6 square root of 2 over 1. We don't need to put it over 1. So it's just 6 square root of 2. So that's going to be our answer there. Now also we could just also do that. As you notice, I just put x is approximately 8.5. So if we needed to find out what the answer was in terms of a decimal, we could do this as well. As 6 times the square root of 2 would give us about 8.5. Most of the time though it's going to be in this form, but just in case you had to round it and get a decimal, you can always do that. 6 times the square root of 2 on a calculator. So we figure out what the square root of 2 is first, and then times it by 6. That would give you, whoops, didn't get the square root of 2. So 2 square root, I hit squared, times it by 6, and there it is, 8.5 approximately. Okay, so back looking at 249, here's the other theorem, 30, 60, 90, right triangle. And again, this one's we want to look at the diagram, we want to look at these equations. There's 2 equations to look at for this one because we have different angles. One's a 30 and one's a 60. And so we got to realize that with that one, the legs here of our right triangle are going to be different sizes. One's going to be shorter and one's going to be longer. The one opposite the 30 degrees will always be shorter. The one opposite the 60 degrees will be longer. And then of course the one opposite the right angle, the 90 degree there, is always the hypotenuse. So in this one you could see the shorter leg is x here, and we're going to base pretty much everything off of that shorter leg. So the hypotenuse is 2 times whatever the shorter leg is. So hypotenuse is always the shorter leg times 2. The longer leg is always the square root of 3 times whatever the shorter leg is. So shorter leg times the square root of 3 is going to give us our longer leg. And so as we look at ones here now, we'll have these 2. We have to really realize we're going to see 2 equations for this one because we're going to define, as we find out what x is, if we need to know what the legs are, then we're going to use 2 equations for it. Okay, so back on page 250, your extra practice 5 to 6, these are all 30, 60, 90 right triangles. You can see it doesn't need to put in both angles. If you have one is 30, you know the other angle's up here is 60, or if this one's 60, you know the other one's 30. So it says to find the values of x and y. So we're looking for 2 side lengths here. They're always going to give us one side length. We would have to know one side length here to be able to figure out the other 2. Write your answers again in simplest form. So we like to go off of that shortest leg. So 15 is the shortest leg here. It's the one opposite the 30 degrees. So 15 is our shortest leg. So we could start by putting down the little equation. I always just write it out like this. So I want to find the longer leg one. Then I'm going to say long leg is equal to short leg times square root of 3. And then just plug it in. So we know our short leg is 15. So x is this one. So we're looking for the longer leg x. X equals 15 square root of 3. And that's all we basically have to do. There's our answer, 15 square root of 3. And then we want to find out what the other one is. So there you can see 15 times square root of 3, same thing as 15 square root of 3. So that's the way we want to write our answer for that one. And then to find y, that's the hypotenuse. We want to write the little equation that has the hypotenuse in it. Hypotenuse is equal to short leg times 2. So we know the short leg is 15. 15 times 2 is 30. So the hypotenuse would have to be 30 then for that one. So very simple on this one. So if they tell us the short leg, then it's pretty easy to figure out the hypotenuse. Just times that by 2. And it's easy to find the longer leg. Just times this 15 by the square root of 3. Now number 6, they give us the hypotenuse, the one that's opposite the right angle. We're trying to find the two legs. So the leg that we want to find first is going to be the shortest leg, because that's going to be always in these ones. We don't see an equation here that has hypotenuse and long leg in it. It's either long leg and short leg or hypotenuse and short leg. So we want to find y first on this one. And so we're going to use this one down here with the hypotenuse equals the short leg times 2. We'll use that one. And we're going to plug in 22 for hypotenuse. X is over here, so basically it's like 2x. So, or 2y I should say. We're going to use y. So 22 is y times 2. Divide by 2, and you'll see that's going to be just 11. 22 divided by 2. So there's y. So if you know the hypotenuse, the short leg will always be half of what that is. So that's not too bad to figure that out. Just half of what this is. Half of 22 is 11. So y is 11. Now to figure out the longer leg, we're going to use our long leg, short leg square root of 3 equation. Use that one. We don't know the long leg, we'll put x here. We do know the short leg now, it's 11, so it's just 11 times square root of 3, and that's easy to do. 11 square root of 3 then would be the answer. And then for number 7, we're told what the longer leg is on this one. So you can see here's 30 degrees, opposite that is x, so this is 60 degrees, opposite that is 9. So we're told the long leg here on this one. We want to find the shorter leg first. So we're going to use this equation with long and short on it in the square root of 3. So our long leg is 9. We're going to put 9 here. X times the square root of 3. We're going to divide by the square root of 3 to solve for x. So 9 divided by square root of 3. That would cancel these square root of 3's out. So now it's just x equals 9 over square root of 3. But we can't leave our answer that way, remember, because this denominator cannot have a radical in it. We have to rationalize the denominator. We got to multiply top and bottom by the square root of 3. And so now we're going to see 9 square root of 3 on the top. On the bottom, square root of 3 times square root of 3 is square root of 9, which actually is 3. So that's going to give us 9 square root of 3 over 3. And we can reduce this 9 and that 3, the ones that are outside the radical. So 3 goes into 9 3 times. So that's just going to be 3 square root of 3 then as an answer for x. So our short leg would be 3 square root of 3. So now that we know the short leg, we can now use that to find the hypotenuse. So we'll use the hypotenuse equals short leg times 2. So we're going to say, okay, this is y equals the 3 square root of 3 times 2. And when we multiply here, we can multiply the number on the outside with the 2. 2 and 3 there can multiply and get 6 square root of 3. And there's our answer for y, 6 square root of 3. All right, let's take a little break. Our joke of the day. So what do you call it when worms take over the world? Global warming. That was a good one. Okay, I wanted to show you this one. This one's in the book, so you don't need to write anything down for this, but you see this yield sign. You've seen these out on the roads. Yield signs are always an equilateral triangle. Okay, all sides are the same on that. So 36 inches here, there are 36 all the way around. So if you have an equilateral triangle, what we can do is we could figure out certain things. It says the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. So that's what we want to do there. So we could break this apart into two right triangles with an altitude here. An altitude is always going from a vertice to the opposite side at a right angle. And so that would break it into a 30, 60, 90 right triangle, because in an equilateral triangle, all the angles would have to be 60 degrees. So if you bisect this 60 degrees, this is 30 on each side. And so now you have 36 this way for the hypotenuse. 18 is half of this 36 here for the short leg. And so then we could figure out what the height is then by doing that. So we could do that right there using the theorem. So our height here, which is the long leg, is going to be the short leg times square root of 3, which is 18 square root of 3. And so that would help us figure out how to find the area. So we could use the height there to find the area times the base, right? Just our area formula for a triangle, 1/2 base times height. 36 is the base right there, and 18 square root of 3 is the height. We multiply all that together, we can get our answer. Okay, so now at the top of 251, For 8 and 9, we're going to sketch the figure that is described. Find the indicated length. Round decimal answers to nearest tenth. So it says number 8, the length of a diagonal in a square is 32 inches. Find the perimeter of the square. So the first thing we're going to do is draw a square. So we're going to sketch the figure. We're going to sketch a square. So just, it doesn't have to be perfect. Mine's not perfect here. But I'm showing right angles on each corner. All the sides will be the same. And we're going to draw a diagonal in here. So I'm going to draw a diagonal and label that 32 for 32 inches. So that diagonal is 32. And what that does is this diagonal is going to bisect these angles here, these 90-degree angles, giving us 45 and 45. So we have a 45, 45, 90 right triangle on each side of this square. We're looking to figure out what the perimeter is, so we need to know what the side length is. We need to know what the leg of this kind of triangle is, and all the legs will be the same. So we're looking for what a leg is. So using our little formula for this one again, we know if we're trying to find the leg, we know hypotenuse and leg for this one. Hypotenuse equal to legs times the square root of 2. So you need to keep these all straightened out, which one is going to go with which. Because you have the 45, 45 is just this one. Always hypotenuse equal to leg times the square root of 2. 30, 60, 90, those have two separate ones. So you got to keep these straight. Hypotenuse we know is 32. We can put 32 here. X is going to go where the leg is. And so now we can divide both sides by the square root of 2. And these square root of 2's will cancel each other out. So X is going to equal 32 over the square root of 2. But we can't leave it that way. So we want to figure this out based on multiplying top and bottom by the square root of 2. So 32 times square root of 2 on the top and 2 on the bottom. And we can cancel out the 32 and this 2. They're outside of the radical. 2 goes into 32 16 times. So we're going to get 16 square root of 2 for a side length. And to try to find the perimeter now, the perimeter is 4 of these. There's 4 16 square root of 2's. So we can say 4 times 16 square root of 2. Well, 4 times 16, we'll see that that's going to end up being 90.5. So we can do that on our calculator. Let's see about this on the calculator here. So we have 4 times 16. We can do that. 4 times 16, if we want to do it this way, that's 64. And so we're going to say, well, what's the square root of 2 again? We're going to times that by 64. And equals 90.5. Here it is. Now we could have done it a different way, I suppose, as well. We could have done this many different ways. We could have started with just right up here without even doing any of this. Since I needed a decimal, I didn't have to do all this radical stuff. I could have just done 32 divided by square root of 2. So 32 divided by 2 square root. Not sure that's going to work it there. No, it doesn't work it out. We're going to say, okay, square root of 2 is 1.414. I'll just round it to that, and I'll say 32 divided by 1.414 equals this. And then there's going to be 4 of those, so times 4 equals that. There's the 90.5. So we could have done it that way as well. Still got 90.5, rounding it to the nearest tenth. Alright, this next one says an isosceles triangle with 30-degree base angles has an altitude of square root of 3 meters. Find the length of the base of the isosceles triangle. So first, let's go ahead and draw an isosceles triangle with base angles as 32 right here. So if this is 30 and this is 30 right here, 30 and 30 makes 60. Our third angle has to be 120 up on top here. We're going to do an altitude from that. So that altitude right there will be our square root of 3. So that means if you bisect this right here, bisect 120, each side is 60. So there's your 30, 60, 90 right triangles on each side. And so what we're trying to figure out is the base of this, what this base is. That's where we're trying to figure out the length of the base. So if we know that this would be our short side is a square root of 3, we need to figure out what a leg is. What's the length of this leg of this 30, 60, 90 right triangle? So we want the long leg is equal to the short one times square root of 3. We know the short one is square root of 3. So it's going to be x here. We might want to say x or whatever. So x is equal to, now that may be confusing because x is not going to be this. So we need the big X. Really probably should have put a y here instead, a different letter. Square root of 3 times square root of 3 would be square root of 9, which would just be 3. So that means that the long leg is 9, not the whole thing. Just this one long leg right here is square root of 9, which is 3. So that's 3 on each side. So 3 plus 3 there, just add those segments up, you get 6 for the base. So the whole thing is the base that we're looking for. Okay, on problem 10 is find the area of triangle DEF. That's the whole big triangle, DEF, the whole thing. Round decimal answers to the nearest tenth. So we see here we have a 30-degree angle here, which means that we're going to have, and we have 90-degree angles shown here in both places. So we have a smaller little triangle, and we know this leg right here is 7 square root of 3. This would be our short leg. This is our 60-degree angle. Eventually we're going to have a bigger 30, 60, 90. This will be also 60 up here. So we have a smaller hypotenuse from here to here that we don't know, and we have this leg, short leg right here, we don't know. So we got to figure out those first, and then we can kind of figure out the bigger one after we figure out this smaller one. So if we know this long leg, we're trying to find the short leg. Let's use that formula with the long leg equals short leg square root of 3. So our long leg is 7 square root of 3 here. This would be like our x. And so now we're going to just divide both sides by the square root of 3 to solve for that x. And when we do that, there's just cancel out and just have a 7 left. So x would be 7, which means your short leg is 7. So there's our short leg, which makes sense because the short leg, the long leg is always the short leg times square root of 3, which that you could see would be. And now for the hypotenuse, we know that that's just going to be 2 times this. I'll just write it out though, just so you can see. We're looking for that right there. We'll call it y. So the hypotenuse is equal to short leg times 2. If we know the short leg is 7, then it's just 7 times 2, which is 14. So we know that this is now 14. So what we know at this point is if this is 14 and from here to here is 14, the whole thing from D to F is 28. So we know that's 28 now. We now need to figure out these other 2 side lengths here to figure out, be able to find the area of this, especially to be able to use the lengths. We don't actually use 28 for the area. It's base times height. This is our base. This would be our height of the bigger one. So let's find the short one here as well. So we know the hypotenuse is 28 of the big one. Shorter leg of this bigger one here now we'll use as 28. The hypotenuse is equal to x times 2, short leg times 2. Divide by 2. 28 divided by 2 is 14. So there's 14. So this is 14 right here for this from F to E. And then we want to figure out the long leg from D to E. So if we know short leg is 14, that's just going to be 14 times the square root of 3. Long leg is the short one times square root of 3. So 14 times square root of 3 is from D to E, and there's that. So now that we know that we have our base is 14 square root of 3, our height is 14, we now can find the area of this whole triangle with the area formula. Area equals 1/2 base times height. And so we're going to plug in our base and our height here. So it's going to be 1/2. Our base is 14 square root of 3, the height is 14. So we could take half of 14 right there, that would be 7. And now we would have 14 square root of 3 times 7. And we could multiply 14 times 7 at this point to get, something there. 98 would be that number, 14 times 7. So 98 square root of 3. And here's where we want to turn to our calculator. So we want to figure, okay, what's the square root of 3? Put that on there. Square root of 3 is 1.73 approximately. Times that by 98. And that would give us 169.7. That's to 1 decimal place. It says to the nearest tenth, which is 1 decimal place. So there we have our answer, 169.7. Okay, so before we end our lesson, let's just do a little practice on page 249. So if you go back to page 249 in your notes, right below the 45, 45, 90, let's go ahead and do 1 and 2 right there. You just want to find the value of the variable. And then right below the 30, 60, 90 theorem, you go ahead and do 3 and 4, find the value of the variables on these ones. So go ahead and stop the video, copy down the shapes here where they're supposed to go. So these two are going to go in the notes underneath 45, 45, 90, 3 and 4 underneath the 30, 60, 90, copy them, and then figure out what the value of the variable is, and then go ahead and play the video again, and I'll show you your answers. Okay, you should have stopped the video, and now you're ready to watch and see your answers for these 4 problems. For number 1, you're trying to find the value of x, so 45, 45, 90. If this is our leg and the hypotenuse is 2 square root of 2, remember the leg, or the hypotenuse, is square root of 2 times whatever the leg is. So the leg would have to be 2 here, because 2 square root of 2 is 2 times the square root of 2. So this one, x would equal 2 on this one. Your leg would be 2, the hypotenuse is 2 times the square root of 2. This one, the hypotenuse is y, so you're trying to find the hypotenuse on this one. The leg is this. So we need to multiply the leg times the square root of 2. So it's square root of 2 times the square root of 2 would be square root of 4, and the square root of 4 would just be 2. So this one, y would equal 2 on this one. And then now for the 30, 60, 90 ones, we're looking for our long leg. Our short leg is the square root of 3. And so remember that the long leg is always going to be the short leg times square root of 3. So square root of 3 times square root of 3 would be the square root of 9, which that would just be 3 then. Square root of 9 is 3, so x would be 3 for number 3. And then for this one, here's one where you have kind of an equilateral triangle. You can see that's equilateral. You have 4, 4, and then this would be 4 here from 2 plus 2. So it's equilateral. All these are going to be 60 degrees. So here's your 30 degrees up here. We're looking for a long leg of a 30, 60, 90 right triangle. Our short leg is 2. So remember, the long leg is always going to be short leg times the square root of 3. So 2 times the square root of 3 would just be 2 square root of 3 for that height. Alright, so that concludes our lesson for 9.2. Go ahead and finish up the assignment for that, and I'll see you in class.